Hey team, it's Mr. Z, and today we're going to simplify some rational functions while also describing any restrictions on the domain. Let's go ahead and take a closer look, shall we? All right, so I do want to understand that we have to do the restrictions on the domain first, but it's always important to look at our function as if it was in factored form. So in this first guy right here, I see in the numerator, I'm going to go ahead and factor out a common factor of y. This is going to lead me to see that y times 2x minus 2 will be over the denominator of x minus 1. I also see a common factor of 2. So I'm going to rewrite the numerator as 2y times x minus 1 all over the denominator of x minus 1. For restrictions on the domain, we look at the denominator. I see x minus 1. What you need to do is you have to ask yourself, when does the denominator equal 0? Well, when x is 1, it equals 0. So this means that the domain of this rational is going to be restricted from negative infinity to 1. Then after 1, it'll carry on. Essentially what this is saying is x cannot be 1. All other numbers work. Now we're going to go ahead and simplify. What you should see is when I'm looking at it, I see 2y times x minus 1. And you have to remember the denominator is a group in itself. Well, they both have the same factors, so I'm able to cancel it out. Remember, 2 divided by 2 is 1. Negative 3 divided by negative 3 is 1. X divided by another number, which is the same, is 1. Therefore, x minus 1 divided by x minus 1 is equal to 1. I do want to point out that some of you might think that they disappear, but that's not actually what happens. Yes, they cancel, and I'm left with just 2y, but actually it's left with times 1 over 1 as a result of the division, and then it cleans up to be 2y. You will go ahead and jump from here to here, and that is okay, but I just want to point out while I'm explaining it that it doesn't quite disappear. We are manipulating this rational and simplifying it, and we have an equivalent expression. However, notice that my domain, I had to look at this first before I do any simplification. Let's go ahead and look at the second example. So I see here that my factoring bug goes, so I'm going to try to factor the numerator. So I'm going to use the same factoring techniques I've been building up throughout this course. I'm looking at x squared, and I see negative 20. And the idea is that I need to figure out how to get a positive x value. I think of my factors of 20, and I see 5 and 4. I want it to be a positive upon combining, so I'm going to make the 4 negative. That way, 5 minus 4, aka 5x, negative 4x, once I include these. Yep, that's my factored form. What type of 5 is it? Positive 5. So I rewrite this as x plus 5, x minus 4, all over x plus 5. If you want to get in the habit, feel free to put a parentheses around it. It's its own group. Now, before I do any simplification, I need to ask myself, what number makes the denominator 0? I can see on sight that it's going to be negative 5. This means that the domain will be negative infinity to 5, and then it'll carry on its business, 5 to infinity. What this is essentially saying is x can be any number but 5. After identifying the domain, I'm able to simplify, and I see a common factor of x plus 5 and x plus 5. I'm going to show you one more time, and after this, I'm no longer going to write the step, but they both become a 1 times x minus 4. This becomes 1 times x minus 4 is x minus 4 divided by 1, which just cleans up to be the factor of x minus 4. Getting the hang of this? All right. Now, this next guy, what we're going to look at is it's the numerator. They're the same, so I just essentially need to factor them. In this case, I just have to make sure that I identify the correct factors precisely. I'm going to go ahead and look at this. Negative 14 x squared. And what I want to get is, how do I get 5x? After some thinking, well, x times x is x squared. I'm thinking about the factors of 14. Well, 7 and 2. What combination would make a positive 5? Well, positive 7 and negative 2 work. I multiply it out. And yes, the green section matches. This is the correct factor. I'm able to rewrite this as an equivalent expression. X minus 2 times x plus 7 all over x minus 2 times x plus 7. Before I do any canceling, I need to ask myself the two questions is, when is the denominator equal to 0? Some of you might be able to see on site that x will be either 2 or negative 7 to make the denominator 0. Some proof of this is if I plug in 2, this is going to result in 2 minus 2, 2 plus 7. Does this equal 0? Well, 0 times 9 equals 0. Absolutely. If I use negative 7 minus 2 times negative 7 plus 7 equals 0. This results in negative 9 times 0, and this is 0 as well. Notice how two factors result in two asymptotes in the domain. So before I cancel out, I'm going to go ahead and write out my domain is going to be the following. It is going to go from negative infinity to, well, which one is it going to hit first, negative 7 or 2? Negative 7. Then it's going to go from negative 7 all the way to 2, and then likely 2 to infinity. To finish this guy up, I could cancel, boom, 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 and I'm left with 1. This last guy I wanted to look at, and basically you should get the idea that by factoring the top, it should look like the denominator has an x minus 1. So I'm actually going to use this fact to my advantage. Now I'm going to remember that the denominator is x to the third plus 0x squared plus 0x minus 1 divided by x minus 1. Divided by. What I'm going to do to factor this guy is I'm going to use long division. So first in line, first in the box, x to the third plus 0x squared plus 0x minus 1. And I'm going to try to figure out how many x minus 1. So I look at my first term and I have to think about x times what number is going to be the leading term. Well, I need 2 more x's. So I need to distribute x squared to both terms. This is going to lead to x to the third minus 1x squared. And it's always being subtracted because it's long division. Now, I'm going to go ahead and distribute this negative, and this is going to be the part that requires the most mental work. X to the third minus x to the third is 0, which is a sign I'm doing it right. A negative times a negative 1 is going to be a positive 1. So I'm going to have positive 1, x squared, and I'm responsible for bringing down the next term, 1 at a time. Now, I'm going to go ahead and ask myself, how do I make x times what is going to be 1x squared? Well, it's just missing an x. So, an x, what type of x? A positive one. So, again, I distribute it to both parts. X times x is going to result in x squared. X times negative 1 is negative 1x. I remember it's long division, so I always subtract. This is going to result in 0, a sign that I'm doing it right. A negative times a negative is going to be a positive 1x. I repeat the process and bring out negative 1. I ask myself, x times what is going to be that leading term? Well, there's already enough x's. It's going to be just 1. I don't even need to change it. It's going to be a positive 1. So, like before, I distribute it to both parts. 1x and negative 1. And after I distribute, it's going to result in 0. A negative times a negative is a positive, with 0, meaning my remainder is 0. Rewriting this is going to result in the following. Remember, your quotient is at the top, and it's going to be multiplied by the factor. So I can rewrite the numerator as x squared plus x plus 1 all over x minus 1. I could have used synthetic division for this as well. My factor is x minus 1, so it will be 1. And for synthetic division, I just lead my leading coefficients, 1, 0, 0, minus 1, and then I open up the doors. Bring down the number. 1 times 1 is going to be 1, becoming 1. 1 times my factor of 1 is going to be a 1, and giving me a 1. 1 times 1 is going to be 1, with a remainder of 0. So remember, this factor is going to be 0 over what I divided it by. This is just going to be a coefficient of 1. This is going to be 1x, and then 1x squared. Notice how I write this right to left. This is a positive fraction. This cleans up just to be x squared plus x plus 1, the same as I got from long division. You might notice that upon doing this, I also have to write the divisor, x minus 1. Notice the yellow region and my divisor. Now, before I go ahead and go any further, my domain is going to be, well, what number makes the denominator 0? 1. So it's going to be negative infinity to 1, union 1 to infinity. After doing the domain, I cancel. Boom, boom, leaving me with just the numerator, x squared plus x plus 1. So what we essentially did is we simplified rational expressions. These were all fraction problems. And I just want to really stress the fact that you identify the restrictions on the domain before you do any canceling. This is it for now. Have a good weekend.